In 1966, an American train blasted past 183 miles per hour, powered by jet engines cannibalized from Cold War bombers. That was a speed record on United States rails that remains untouched. But almost overnight, the groundbreaking experiment disappeared, leaving a legacy buried under decades of lost ambition. How did a machine that could have redefined American travel become a forgotten footnote? The answers reveal more than just the fate of a train. They expose the moment America stepped back from the future. American passenger railroads in the 1960s were caught in a downward spiral. After World War II, the rails that once carried nearly every long-distance traveler in the country watched their numbers collapse. In 1946, U.S. intercity trains moved more than 118 million passengers. By 1966, that figure had plunged to just 18.5 million, a staggering 84% drop in only 2 decades. Personal cars and the growing web of interstate highways offered freedom and convenience that trains struggled to match. Jet airliners, now crossing the country in hours, drew away business travelers and vacationers alike. Rail's share of intercity passenger miles, once dominant, fell below 1%. While American ridership dried up, the world looked in a different direction. In Japan, the Shinkansen bullet train debuted in 1964, running from Tokyo to Osaka at speeds that seemed futuristic and immediately attracted millions of riders. The Shinkansen carried 35 million passengers in its first full year, nearly double the entire U.S. intercity rail market. European countries, too, were pouring resources into electrified lines and modern rolling stock, building the foundation for high-speed corridors that would soon become the envy of the world. The contrast was impossible to ignore. American railroads, still running aging diesel locomotives on tracks built for a slower era, faced a stark choice: adapt or fade away. The financial pressure was relentless. By the mid-1960s, passenger service was a money-losing proposition, with railroads subsidizing empty trains in hopes of staving off total collapse. Industry leaders scanned the globe, searching for a breakthrough that could reverse their fortunes without the crushing cost of new infrastructure. Against this backdrop, radical solutions began to look less like science fiction and more like necessity. Jet propulsion, borrowed from the world of military aviation, offered the promise of speed that could rival the latest airliners, all while using the rails already in place. For a brief moment, it seemed possible that American trains might leapfrog the competition, delivering a futuristic experience without the billions needed for new tracks. The urgency for innovation was not just about pride or prestige, but about survival in a market slipping away with every passing year. Don Wetzel did not waste time on blueprints or bureaucracy. Once the New York Central gave the green light, he and his team at the Collinwood Technical Center in Cleveland got to work. Their base was a Budd RDC-3 railcar, originally built in 1953 for quiet passenger runs through Michigan. Now it sat stripped bare in a workshop, waiting for something radical. The centerpiece of the transformation came from the deserts of Arizona. 2 General Electric J47-19 jet engines were bought for just $5,000 as military surplus. These engines, once mounted on the wings of B-36 bombers, had powered Cold War patrols over the Arctic. Now they were headed for the roof of a passenger train. Wetzel personally oversaw the procurement, making sure the engines were modified to run on standard diesel fuel instead of aviation gas, a tweak that made maintenance simpler and costs lower for the experiment. The design team faced a tight deadline. From the moment the project began, they had less than 20 days to turn the idea into a working machine. Inside the Collinwood shop, seats were pulled, wiring rerouted, and the roof reinforced to handle the combined 10,400 pounds of thrust. More than 50 instruments were installed to measure stress, speed, temperature, and vibration, every variable that could spell success or disaster at 180 miles per hour. Aerodynamics mattered as much as raw power. The original RDC's blunt front end would never cut it at jet speeds. Wetzel's wife, Ruth, a commercial artist, sketched a new nose cone, sleek, black, and curved like the shell of a beetle. The shop crew built her design out of sheet metal, giving the machine its unmistakable look and its nickname, the Black Beetle. The jet engines were mounted in a nacelle recycled from a B-36 wing module, perched high above the car's center line. The whole assembly looked more like a science experiment than a passenger train. Wetzel was not just the mind behind the project, he was hands-on, crawling over the car, checking every fitting, and making sure nothing was left to chance. He knew the risks. But in less than 3 weeks, the M400 was ready to roll out of the Cleveland shop. What had started as a wild idea now sat on the rails, engines gleaming and nose pointed toward history. Jet propulsion wasn't just a technological gamble, it was a financial pitch. The New York Central's engineers made a bold claim. America could leap into the high-speed era without building a single mile of new track. In contrast to Japan's Shinkansen, which required billions for dedicated lines, the Black Beetle's promise rested on the rails already stretching across the continent. The logic was simple. Why pour money into concrete and steel for new corridors when thousands of miles of track already ran through the nation's biggest cities? The jet train, they argued, could deliver headline-grabbing speeds using infrastructure that railroads owned outright. This idea had powerful appeal at a time when passenger service was bleeding money. The cost of constructing new high-speed lines, as seen overseas, was out of reach for private American railroads already struggling to keep the lights on. By using surplus military engines and a retired Budd RDC-3, the Black Beetle's conversion cost came in at a fraction of what even a single mile of new track would demand. For railroad executives and shareholders, the numbers seemed to add up, at least on paper. No new right-of-way, no land battles, no massive government subsidies. The M497 was positioned as a shortcut to the future, sidestepping the staggering capital costs that had kept true high-speed rail out of reach. It was an argument built on pragmatism, not just on dreams. If jet speed could be achieved without the price tag of foreign projects, perhaps American railroads could compete with airliners and interstates after all. The Black Beetle became the poster child for this vision, a rolling experiment in whether ingenuity could outpace deep pockets. The Black Beetle's promise of high-speed rail without new tracks began to unravel as engineers confronted 3 insurmountable barriers. The first was fuel. The J-47 and 19 jet engines built for bombers devoured fuel at a rate that dwarfed any savings from using old infrastructure. On paper, the Black Beetle could cover ground faster than any diesel, but it burned through diesel fuel several times faster than a conventional locomotive. Each burst of speed came with a penalty, a fuel bill so steep that no passenger revenue could ever hope to cover it. Engineers estimated that mile for mile, the cost to run the jet train would be catastrophic compared to even the least efficient diesels of the era. Then came the noise. The roar of the twin jets could be heard for miles, far exceeding the volume of any train or truck. Decibel levels at full throttle reached the pain threshold, making station stops in cities and towns unthinkable. The jet blast posed a direct hazard to anyone near the tracks: track workers, bystanders, even passengers waiting on platforms. Safety experts warned that a single misstep near the exhaust could result in severe injury, and the danger zone stretched far beyond the rails. The Black Beetle was not just loud, it was a rolling hazard that threatened the very people railroads depended on to keep trains moving. Finally, the tracks themselves became a problem. At 183 miles per hour, the dynamic forces on conventional tracks soared. Rails designed for 70 miles per hour freight service suffered accelerated wear with each test run. Ballast shifted, ties splintered, and the maintenance curve steepened sharply. Any plan to run jet trains regularly would have forced railroads to rebuild miles of track to withstand the pounding, eliminating the cost advantage that made the project attractive in the first place. Each engineering report delivered the same message: the dream of speed without new infrastructure was a mirage. The Black Beetle had proven what was possible, but also what was impossible to sustain. 50 instruments lined the interior of the Black Beetle, each wired to capture a different facet of the experiment. Sensors tracked speed, vibration, temperature, and stress at dozens of points along the car and its axles. Telemetry units sent real-time data from the front wheels, recording how the rails responded as the jet engines pushed the car far beyond normal limits. Engineers collected ride quality metrics, bearing temperatures, and oscillograph traces on magnetic tape, building a technical record that would be pored over long after the run. Data from these systems formed the heart of the study. The test program was strictly temporary by design. New York Central authorized the M497 as a feasibility study, not as a prototype for regular service. The project's mandate was clear: gather as much data as possible in a short window, then return the car to its original configuration. There was no plan for passenger seating, no schedule for future runs, and no budget for further development. The focus was on measurement, not commercial deployment. Data collection spanned only a handful of days, with the test runs concentrated over a single weekend in July 1966. The engineering team worked with the knowledge that once the data was in hand, the experiment would end. This approach allowed the railroad to minimize risk and cost, but it also meant that any hope for a broader future would hinge entirely on what the instruments revealed. The Black Beetle's brief career was defined by its role as a rolling laboratory, a machine built to answer questions, not to solve the larger crisis facing American rail. Once the measurements were complete, the urgency faded, and the car's purpose was fulfilled. The experiment's temporary nature made it easy to walk away, no matter what the data showed. Federal spending in the 1960s poured into highways and airports, reshaping how Americans moved across the country. The Interstate Highway System, launched by the 1956 Federal Aid Highway Act, consumed billions in public funds, laying down thousands of miles of concrete each year. By the mid-1960s, highways received more than 5 times the federal dollars allocated to all forms of rail. At the same time, the aviation industry soared on a wave of government investment. New airports, air traffic control systems, and generous subsidies for commercial carriers. Airlines and automakers, backed by powerful lobbies, made sure their interests stayed at the top of the national agenda. While the Black Beetle flashed across the rails at record speed, electric and diesel technology advanced quietly in the background. General Electric and EMD pushed out new diesel-electric locomotives with better efficiency and reliability, while the Northeast Corridor eyed electrification to boost speed without the spectacle or the noise of jet engines. The Metroliner project, started just 2 years after the Black Beetle's run, promised 125 miles per hour service using proven electric traction. These projects attracted steady funding and political support, seen as safer bets for a struggling industry. Private railroads, left to fend for themselves, faced a losing battle. The New York Central's investment in the M497 came from shrinking corporate budgets, not public coffers. Unlike the Shinkansen in Japan, which was built with government backing and a clear mandate, American railroads had no federal champion. Congress debated the future of passenger service, but most bills favored roads or runways. The Department of Transportation, created in 1966, focused its early years on highways and aviation, leaving rail innovation to languish. Without sustained investment or policy support, even the most spectacular experiments faded quickly. The Black Beetle's test run drew headlines, but the momentum shifted elsewhere. Electric and diesel trains, not jet-powered prototypes, became the focus of research and funding. The priorities were clear in every budget line and policy meeting. America's future would be built on asphalt and jet fuel, not steel rails. After the last test runs, the Black Beetle rolled back into the shop at Collinwood, stripped of its jet engines and aerodynamic nose. The streamlined shell Ruth Wetzel had designed was unbolted and set aside. Technicians removed the twin J-47s from their mounts, returning the battered Budd RDC-3 to its original form. The jet nacelle, once the centerpiece of a record-setting experiment, was lowered by crane and carted away. The car's wiring was rerouted, seats reinstalled, and the battered roof patched over. For a while, the M497 returned to ordinary duty, running quiet commuter trips with no trace of its brief, spectacular career. But in the years that followed, the railcar's fate was sealed by the same forces that had driven its creation. With no further funding, no commercial orders, and no federal interest, the Black Beetle became a parts donor. Service logs from the late 1960s and the 1970s show M497 listed as a source for spare components, its brakes, doors, and electrical panels cannibalized to keep other RDCs moving. The jet engines were stored for a time, then sold off as surplus. The nose cone vanished into storage or scrap, leaving only faded photos and engineering drawings as proof it ever existed. By the early 1980s, the shell of the M497 sat idle in a rail yard, stripped of anything valuable. The New York Central itself no longer existed, absorbed into Penn Central and then Conrail as the era of private passenger rail ended. With no historic designation and no preservation campaign, the car was quietly cut up and hauled away for scrap. There was no ceremony, no plaque, no effort to save the machine that had once outrun every train in America. The record of 183.68 miles per hour remained, but the Black Beetle itself was gone. Its brief, improbable life ended not with a crash or a fire, but with the slow, methodical dismantling of a machine that had outlived its purpose. Nearly 6 decades later, no American train has matched the Black Beetle's record on conventional rails, a testament to stalled ambition as other nations race ahead with high-speed rail. The real barrier is no longer technology, but the choices we make about what our future should look like. What innovations are we willing to leave behind for convenience? The tracks we invest in today determine where we can go tomorrow.